Okay, so we look at the JFET. We look at the JFET in self-bias configuration mode. So this is the JFET self-bias configuration. So this is what we're going to look at, the self-bias configuration. Okay, so we solve this question using the mathematical approach instead of the graphical, but we use the mathematical approach. So the question says determine the following. We have the VGS, the ID, the VDS, the VS, VG, and VD. So the ground to source voltage is the first question that we have to solve. So how do you go about it? Okay, so let me just erase this. Okay, so this is the circuit given. So we have this one here, the transistor there. So at this point here, this is where the drain voltage is. At this point here, we have the gate voltage. Then at this point here, we have the source voltage. Okay, so now the in between the gate voltage and the source voltage, this is where the VGS is found, where the gate to source voltage is found. Then in between the drain voltage and the source voltage, this is where our VDS is found, meaning the drain to source voltage. Okay, so now since this one, we know that this is the gate side, the drain and the source, you find that your VG, this one here, has to be equal to 0, together with the IG given there is equals to 0. There is no current which is going through this circulation. Hence, we are going to have a loop which looks like this. So this is our loop. So now how does current move? It's moving in this direction here, following this loop. So now using this loop, we can come up with a formula for us to determine the current or the voltage that goes around this loop. Since here we have IG is equals to 0, what about on this one, the VS here? What is the current, what is the voltage at this point, the current that goes through the source? Okay, so using this loop here, we can come up with the formula. We have, the equation for us to determine the current that goes through that VS. We have V equals to IR. This is Ohm's law. V is equals to IR. So according to this loop here, for us to calculate the voltage at this point here, we are going to multiply the current at this point together with the given resistor, which is 3K ohm. Okay, then at this point here, we have IG is equals to 0. Then at this point here, for us to calculate the voltage at this point here, since we have that Ohm's law, V is equals to IR, to calculate the voltage at this point here, we will multiply the current that goes through this source, which is the IS, multiplied by the given resistor, which is 2K ohm. Okay, so we will start. We're going to have this formula here. It will be the current that goes through that 3K here, the current that goes through here. It is the IG. So we have our IG there. We multiply by the resistor given there, resistor, which is our RIG, minus, this is our VGS, VGS minus, we have this current here, this voltage at this point here. So we multiply the current that goes through here, which is our IS. Our IS, the current, the source current is the one that goes through this source here. So the source current, we multiply the source current together with the resistor at this, the resistance given, at this source, which is the 2K. So we're going to have our IS multiplied by RS, which everything has to give us equals to 0. Okay, so you find that now the current from the drain, it goes in this direction. So the same current from the drain, it will be the same current that will go through the source current there. Since here we don't have anything, Ig is equals to 0. So we find that the current that will go through this resistor here, it will be the same current that will pass through this drain. Therefore, we have our Id equals to Is. So where there is Is here, we can substitute with our Id. So let's start now substituting. We have our Ig. Okay, our Ig said that it is 0. Open bracket. What is our Rg? Our Rg is 3k ohm. So we have our 3k there minus VGS minus our Is. We said that Id is equals to Is. So where there is Is, we substitute with our Id. Is and Id is just the same thing. Then our Rs here, we've been given that it is 2k. So substitute with our 2k, or let me just say Rs for us to come up with the formula. Rs, okay, which is equals to 0. From there, what is 0 times 3k? You're going to have a 0. So 0 minus V GS minus I D R S is equals to 0. Correct like terms 0 and that goes that side, so it will still remain 0. So we are going to have our VGS. Let's take the VGS the other side. So we are going to have VGS is equals to negative ID RS. So now for us to have to remain with our ID here, we are going to divide throughout by what? Negative RS, also here by negative RS. So meaning the negative and negative disappears, RS and RS goes. So meaning our ID is equals to VGS over RS. Remember that there's this negative sign here. Okay, so this one becomes our first formula. This one becomes our first formula that we are going to be using. ID is equals to negative VGS over RS. Okay, so since now this one becomes our first formula, then how do you calculate now this one, the VGS there? So for us to calculate that VGS, we'll use this formula. Let me just erase this part and we take our VGS up there. Okay. All right, so we take our VGS. Okay, so this is the formula that we have. We have this formula. Okay, so now this is the formula that we are going to use. We have our ID, ID, which is equals to IDSS, open bracket, 1 minus VGS over VP squared. Others here they will use the VGS off. You can use VP or the VGS off. So we have this formula. So from this formula here, we've been given that our ID, we've calculated that ID is equals to negative VGS over RS. So where there is ID, we substitute with this formula here. So we are going to have negative VGS over RS, which is equal to our ID, IDSS, open bracket, 1 minus VGS over VP squared. So from there now, for us to calculate, we have our VGS. Now, how do you calculate this VGS? Because that's what they want from the first question. Okay, so we start substituting. So to be negative VGS over our RS here, we've been given that it is 2K. So which is 2000 equals to our IDSS here, we've been given that it is 6 milliamps. This one has to be amps. Okay, we've been given that it is 6 milliamps. So we just write a 6 milli here, open bracket, 1 minus our VGS is the one that we have to calculate over. What is our VP? We've been given that it is negative 2. So we have negative 2 there. We close squared. From there, we'll continue. So to be negative VGS over 2000, which is 2k, equals to 6m, open bracket, negative and negative becomes a positive, so we're going to have 1 plus VGS over 2. Then you square it. Okay, so now from here, how can we expand this? Because we have a square. Let's try to expand this and see what we are going to get. Okay, so I'll expand this. I have my 1 plus VGS over 2 here. Then the other side again, I'll have the same 1 plus VGS over 2. So let's try to expand this. What is 1 times 1? We have a 1. 1 times VGS over 2, that's plus VGS over 2, plus VGS over 2 times 1, we have VGS over 2. VGS over 2 times VGS over 2 plus, so it will be VGS squared over 4, because VGS times VGS, that's VGS squared. 2 times 2, we have a 4 there. Okay, so we have this. So from there, what do we do? 1 plus, these are like terms, VGS over 2 plus VGS over 2, they're like terms, we can add them. So VGS over 2 plus VGS over 2, it's the same as in half, which is 1 over 2 VGS plus 1 over 2 VGS. We're going to have a VGS plus VGS squared over 4. This is half plus half, which is the VGS. So we're going to have this. So from there, this is what we are going to write here. Okay. So I will erase this part. And okay, and get this as our solution from the expansion. So this becomes our solution from the expansion, what we've expanded there. Okay, so remember that the first thing here we have it's negative VGS over 2000, which is equals to 6 milli. Then this one, they're in brackets. Okay. This what is in the brackets, we have expanded this, so we have this. Okay, so now from there, what do we do? We have our negative VGS over 2000, which is equals to the 6 milli multiplies everything in the bracket. 6 milli times 1, we have 6 milli. 6 milli times positive VGS, we have plus 6 milli VGS plus 6 milli times 6 milli times VGS squared over 4. So just divide, that is 6 milli divided by 4. So 6 milli, you divide it by 4, we're going to have 1.5. We're going to have 1.5 milli, 1.5 milli VGS squared. Okay, from there, these two are like terms. VGS over 2 K, which is 2000, and the 6 milli VGS, they are like terms, so we'll collect them. So we'll be like, this one has to go the other side, then we'll remain with the 0 here. Okay, so we're going to have 0 is equals to 6 milli plus 6 milli VGS. Here it's a negative, when it comes to the other side, it will be positive, plus VGS over 2000, which is 2K. From there, plus 1.5 milli VGS squared. Okay, so from there now, we are going to have our 0 equals to the 6 milli here plus. Now that one here, what is 6 milli plus 1 over 2000? So you just divide, that is 1 divided by 2000. That is 5 times 10 raised to the power negative 4 plus 6 milli. You're going to have 6.5 here. We're going to have 6.5 milli, 6.5 milli VGS plus 1.5 milli VGS squared. Okay, here you just add, that is 6 milli plus half, what is 6 milli plus VGS over 2000? You're going to have 6.5 milli VGS plus 1.5 milli VGS squared. Okay, from there now, this becomes the quadratic equation because of the VGS and the VGS there. So the quadratic equation appears like this. So we're going to have 1.5 VGS squared plus 6.5 milli VGS plus 6 milli equals to 0. So meaning this one becomes our A, this one becomes our B, and this one becomes our C. Then we can solve this from the quadratic equation. So the quadratic equation, we are going to have the VGS is equals to negative B positive or minus the root of B squared minus 4AC over 2A. Okay, from there we have our VGS is equals to, what is our B? Our B is 6.5 milli, so that's negative 6.5 milli positive or minus the root. What is our B? That's 6.5. 6.5 milli, you square 8 because B is squared. Square 8 minus 4 open bracket. What is our A? 1.5. Here it's 1.5 milli, sorry, 1.5 milli. What is our C? Our C is 6 milli. Okay, so this one here is supposed to be VG 1.5 milli, 1.5 milli VGS squared. Okay, so from there, this one, everything over what? Over 2 open bracket. What is our A? Our A is 1.5 milli. We close. Okay, from there now, our VGS is equals to negative 6.5 milli positive or minus. Then this one here, now we perform the calculations first. Okay, others who doesn't know how to perform the calculations step by step, I'll just try to go step by step. Okay, so I'll have my 6.5 milli, 6.5 milli squared, 6.5 milli squared. I'm going to have 4.225 times 10 raised to power negative 5 minus, if I punch what is 4 times if I punch what is 4 times 1.5 milli times 6 milli, I'm going to have 1.2. 4 times 1.5 milli times 6 milli, I'm going to have 1.2 times 10 raised to power negative 5. This is what I'm going to have there. Then everything, I'll divide everything by what is 2 times 1.5, that's 3 milli. So I'm going to have 3 milli. Okay, now from there, what's next? Let's try to deal with what is there, what is here. I subtract 4.225 times 10 raised to power negative 5 minus 1.2 times 10 raised to power negative 5, meaning my VGS here is equals to, still keep the negative 6.5 milli, positive or minus, then the root now. So from there, what is 4.225 exponent negative 5? You subtract minus 1.2 exponent negative 5. We're going to have 3.025 times 10 raised to a negative 5. From there, we divide everything by what? By 3 milli. Okay, we have this. Let me just try to expand the board. Okay, so we have this now here. From there, we're going to have our VGS is equals to negative 6.5 milli, positive or minus. Then what is the square root of 3.025 times 10 raised to power negative 5? We're going to have 5.5 5.5 milli. We're going to have 5.5 milli. You divide it by 3 milli. From there, meaning our VGS is equals to negative 6.5 milli plus 5.5 milli over 3 milli, or negative 6.5 milli minus 5.5 milli over 3 milli. Okay, because there's a square there, we're supposed to have two answers. We are supposed to have two answers. I'm just trying to expand both so that at least we can have a space for our answers. Okay, so from there we're going to have our VGS is equals to, now there, if you perform the calculation of negative 6.5 milli plus negative 6.5 milli plus 5.5 milli, we are going to have negative 1 milli. So here we're going to have negative 1 milli, then negative 1 milli. Let me just try to show it here. Negative 1 milli divided by 3, which is equals to, if you divided negative 1 milli by 3 milli, negative 1 milli by 3 milli, you're going to have negative 0.33 amps. Okay, this is milli down there. So if you divide what is negative 1 milli divided by 3 milli, you're going to have negative 0.33 amps. I mean, sorry, not amps, but the voltage. This is our VGS, the gate to source voltage. Okay, so there we are going to have the voltage given. Okay, then here, or now if we do perform the calculation from the other side of negative 6.5 milli, negative 6.5 milli minus 5.5 milli, we are going to have negative 0.012. You divide it by 3 milli, meaning the answer for this, if you divided that by 3 milli, the answer for that becomes negative 4 volts. Okay, so these ones becomes our two answers for the VGS, negative 0.33 VGS. We're going to have negative 0.33. Let me just try to indicate it here. So this one here, the VGS, we're going to have negative 0.33 volts. And remember that here down here, the answers that we've calculated to have negative 0.33 voltage or negative 4 volts. Now, if you look at your diagram here, this circuit that you've been given the circuit that your VP here is equals to negative 2. Your VP here is negative 2 volts. So meaning the VGS has to be lower than this. It's not supposed to be above the VGS off, because this is the VGS off. Now the VGS off is negative 2. So meaning the answer that you are supposed to have has to be less than that. Okay, so meaning negative 4 here. The answer that you've calculated to be negative 4. This one won't be our answer. The correct answer will go with this one, because this one is the one which is in line with the negative 2, which is the VGS off. So negative 0.33 becomes our answer for the VGS there. So negative 0.33 volts. This one becomes our answer. Okay. So from there, how do you calculate now our ID? Our ID becomes simple because now we know the VGS. So we said that our ID is equals to negative VGS over RS. Okay, this is what we substituted there when we started. Okay, so our ID is equals to negative VGS over RS. So from there, what do we do now? it will be our ID is equals to negative. What is our VGS? It is negative 0.33. You close over. Our RS, it's 2K. This is our RS here, the 2K resistor, which is 2000. So our ID equals to negative, negative becomes a positive. And what is 0.33? You divide it by the 2000. You're going to have 1.65. Going to have 1.65 times 10 raised to the power negative 4 amps, because this is the current. Or you can have our ID equals to, move the point here, remove the point here, becomes 0.165 milliamps. Okay, so there our ID calculated to be 0.165. So this one equals to 0.165 milliamps. Let's go to the VDS. How do we calculate the VDS? So for the VDS, I would like to use, I would love to use the circuit here to verify everything. Okay, so I will erase this and try to get the formula from the circuit. Try to make the formula from the circuit. Okay, so we start. So now, how do we calculate our VDS? Our VDS, we said that VDS it is at this point here. So for us to calculate the VDS at this point, to start, the current will be moving in this direction. So since the current is moving in this direction, we have to know we know the voltage there. This voltage is what we call the VDD, the drain to drain voltage. Then we have the voltage here, the voltage here, and the voltage there. So we have to know all these voltages. So we start with how the current is moving. So it's moving in this direction. This is what we are going to follow. So we are going to have our VDD there minus the voltage at this point here. It will be ID because that's the drain current which is going through this resistor. So we're going to have our ID there. We'll multiply by the RD for us to get the voltage there. Minus, we have the VDS there. This is our VDS here. Minus this one here. And the voltage at that point, which is ID, because we said that the voltage, the current that has to go in this is the same current. The current that has to go in this resistor here, it is the IS. But we know that IS is equals to what? ID. Why? It's because here the IG doesn't perform any function. IG is equals to 0. So we have our ID RS there, which is equals to 0. It goes to the ground. Okay, so from there now we're going to have our VDD minus we want our VDS, so it will be our VDD minus ID RD. We take this, the VDS, the other side, so that it becomes the subject of the formula. So we'll continue with minus ID RS, this one here, which is equals to this one. When it crosses an equal sign, if this one crosses an equal sign, becomes positive, so it will be VDS. Okay, therefore VDS is equals to VDD. Then here we have like terms of ID. You can factor out ID. So minus ID, open bracket. If you factor out ID, you're going to remain with RD. Then negative into negative, we have a positive there. So it will be plus RS. Yeah, so this one becomes our main formula. VDS is equals to VDD minus ID, open bracket, RD plus RS. This one becomes our formula that we are going to use for us to solve the VDS. Therefore, VDS is equals to our VDD. We've been given that it is 24. This is our VDD here, 24, minus our ID. We've calculated our ID to be 0. This is our ID here, 0.165 milliamps. That's our ID. This is our ID, 0.165 milliamps. So we're going to have 0.165 milli, open bracket. What is our RD? Our RD, this is our RD here, the drain resistor, which is 1K or 1000 plus our RS, we've been given that it is 2k. 2k we close. So from there it will be our VDS is equals to 24 minus 0.165 milli, open bracket. What is 1k plus 2k? We're going to have a 3k there. Okay, so our VDS is equals to 24 minus. So now what is 0.165? You multiply by 3k. You multiply that by 3k, we're going to have 0.495. So meaning our VDS there is equals to, if you subtract minus 24, so 24 minus 0.495, we're going to have 23.505 volts. This is the voltage for VDS. So we go there, VDS here, which is equals to 23.505 volts. We go to the VS. How do you calculate the VS? Okay, allow me to erase this part here so that we can use it, because all the formulas are going to be coming from the circuit. Our VS, okay, so our VS is what they want us to calculate the voltage at this point here. So our VS is equals to VGS plus VG. VGS is equals to VG minus VS. Okay, so for you, VGS is equals to VG minus VS, then you make VS the subject of the formula, meaning it moves here. So we just the VGS is equals to VG minus VS. So we have VG minus VS, then we make VS the subject of the formula. So how do you make VS the subject of the formula? It goes on the other side. So we're going to have this one moves. I mean, we make this one go the other side, then this one it comes here. Okay, so meaning we're going to have our VS, which is equals to VS equals to VG minus VG minus VGS. Okay, so this is our formula. VG is equals to VS is equals to VG minus VGS instead of this one here, because for this one here, if you move this one here, we are going to have VS minus VG, this one here. So we have to make VS the subject of the formula. So this one has to move here, then this one comes the other side here. So this is what we are going to have, meaning VS is equals to VG minus VGS. Okay, so now from there, I think this one, from this one was, yeah, not this one here, because this one, if you move this one here, you're going to have VGS is equals to VS minus VG. Yeah, so we're going to have this one here. This one becomes our formula. It's the one that we are going to use. So now from there, it's just a matter of substituting. This is our VGS here, so it will be V minus plus this one equals to this. Okay, so we follow the same direction, so it will be VG minus VS minus this one equals to 0. We have there the VG minus VGS minus VS is equals to 0. Then from there, this you have VG minus VGS minus VS equals to 0. From there, we want to solve for what? We want to solve for VS. So VS moves here. So here we're going to remain with the VG minus VGS Vg minus Vgs is equals to Vs. Yeah, so which is this one here. So this one becomes our formula. Now from there, we just do the substitution. So how do we substitute now? We've been given, let me just try to take this up. Okay, so now how do you make the substitution? We've been given the Vg, we know that the Vg here, it's 0, but the VGS is what? Negative 0.33. So we're going to have our Vs is equals to our Vg, which is 0 minus our VGS, it's negative 0.33. So meaning our Vs is equals to 0 minus, negative times negative, that's a positive, so to be plus 0.33, which is equals to 0.33 volts. This one becomes our answer for our Vs. What if we use, let's try to prove something here. What if we use, for us to calculate the Vs, we say Vs is equals to Is Rs, whereby the Is, this one, it is the drain current, which is equals to ID Rs. So from there, Vs is equals to our ID. What is our ID? We calculated our ID to be 0.165 milli. We have 0.165, or 0. There's a 1 here, okay, and a point. So 0.165 milli. Let me just try to erase this and write it properly, write it nicely. Okay, so from there we're going to have our ID, that's 0.165 milli, multiplied by our RS, that's 2K, which is 2000. So Vs is equals to, if you perform the calculation there, that is 0.165 milli, you multiply by 2000, you are going to have 0.33 volts, the same as this one here. Okay, so we can do this, or we do the other way around. So this is how we are going to do it. Okay, so here it comes out to be 0.33 volts. Let's try the other way. We can even use this one here for the VDS. This one for the VDS. We can use this one for the VDS. Now here, for us to use this one for the VDS, we don't know the drain voltage there. We haven't yet calculated the drain voltage, so it will be hard for us to use for the VD. Okay, for the VDS. So we can use these two. It still comes up with the same answer. We go to the VG. We say that VG is equals to what? VG is equals to 0. VG is equals to 0 volts. The VD, how do you calculate now the VD? So VD, we know the VS there. Our VD can here. This is our VD. So to be VD minus VDS minus VS is equals to 0. So to be VD minus VDS minus VS is equals to 0. From there, let's make VD the subject to the formula. So we're going to have VD is equals to VD is equals to VDS plus VS. This is our VDS. This is our VD. So VD is equals to, so we're going to have VD we're going to have the VD minus VDS minus VD is equals to 0. Are we sure, or we have left out something? It starts from here. This one here it will start from here going down there. So since it is starting from here going down there, we are going to have that. So now it will be VD is equals to, what is our VDS? Our VDS, we calculated our VDS to be what? to be 23.505. So we have 23.505 plus what is our VS? That's 0.33. So our VD is equals to 0.33 plus 23.505. We're going to have 23.835. This one becomes your answer. Final voltage 23.835. 20. So this one equals to 23.835 volts. So this is how we solve the calculation if you are dealing with the self bus configuration under the JFET. Thank you.